in a certain neighborhood, there may be different locations where you could put an aggregation point, like a cabinet. Now, normally when you would have a manual design process, you would have to pick a certain spot, create your network from there, and you don't have the time to really see if you would move this location to another place in the neighborhood, what it would do with your overall design, with your overall cost.
This is Raf Meersman speaking, CEO of ComSoft. ComSoft is a software empowering you to efficiently design future-proof networks. And in this episode, we're going to discuss with Raf how one can actually do this in a nearly fully automated way, and that high accuracy data is actually needed for that. We're going to also discuss with Raf how next generation technologies like machine learning, AI, and even LIDAR can help you to boost this data accuracy and make better business decisions. So if you have ever wondered what would happen if you go above ground instead of below ground, and what this would actually mean to the bill of material and also to the overall build-out cost, then this interview is certainly something for you. So without further ado, let's get into the interview. You are listening to Become Fiberminded, a podcast about fiber optics. Each week we are bringing you insightful conversations with industry experts so you can become fiber-minded as well and get the success you deserve. I'm your host, Christian Till, and you can follow me on fiberminded.com. Welcome to Become Fiber-Minded. Hi Raf, welcome to this episode of Become Fiber-Minded.
Hi Christian, it's a great pleasure to be here. Thanks for inviting me.
Much appreciated. So Raf, for your audience, could you give us a little bit of background on yourself and your company?
Yeah, sure. I'm an electrical engineer by education, but I've always been, since 1999, that is, when I graduated at the University of Ghent, I've always been in the telecom world, and actually very much into the fiber world as well. So yeah, it's already been like 22 years, so time flies. I'm amazed when I look at that myself. Of course, in the beginning, it was all about late 90s. It was more about fiber in the backbone. So it's only been then after, I would say, 5-6 years that my attention also shifted to the fiber in the access part of the network. But since then, it's always been about fiber for me.
And so you're currently the CEO of ComSoft Planning Software?
Yes. So also there, yes, I started my career at ComSoft in graduating and in 99, first as a developer and a consultant working around the development and the projects consulting in fiber design projects. And then I was very lucky because after doing this for 5-6 years, I was able to get personally the lead also of the R&D activities within ComSoft. And that's where this whole fiber to the home focus was a bit my initial project in the R&D. And then I had another big opportunity in 2012 to take over some shares and become a shareholder and CEO of the company since 2012. So really been my whole career with ComSoft, but only the last 10 years now in a leading role within the company.
And with your programming background, do you still code a little bit on the background or you focus more on the administrative task?
Yeah, it's unfortunate that I've had to drop that activity. I've hanging on to it for a very long time, but in the end I had to let go. So you have to make some choices, especially when we've been growing very fast over the past years. You do notice you have to focus on the key tasks. So it's unfortunate because it's still, a lot of my passion is in the coding and in the development of the software itself.
I can imagine. So you mentioned that the company recently grew quite a bit. So could you give us some background on ComSoft itself?
Yes. So we started up the company in the late 90s with the focus of designing or developing software for planning of telecom networks. Initially backbone networks, like I mentioned, but then since 2004, I had that R&D project where we looked at fiber to the home as a new opportunity and an upcoming move, and a huge, like one in a lifetime change of the network. And we saw a lot of opportunities and challenges there as a company. So we started developing a software that would automatically, or to a high extent, automatically design such networks based on GIS data. In fact, the initial days, we went into meetings with several players in the market, introducing our ideas and our ambition. But I would say the first couple of years, there were more doors shut, like, oh, what you're going to try to do, it's never going to work. This is not possible to replace the knowledge that is inside a manual planner that has been doing this kind of network planning for years. But we insisted. We went on, and then in 2008, so 4 years after starting really core research, we did our first project, our first fiber design project, and by coincidence, more or less, we ended up in New Zealand, which is basically the other side of the world. You can't go any further than that. But in fact, there was a big benefit to it because our software was obviously in a very early stage. So it was very interesting that we could work all day in our office time to solve some issues or get things done. And then, like in the late evening, middle of the night, we would have meetings with the client. And then the next morning, we could go back, and so we could optimize our time in terms of solving issues initially and delivering to the client and meeting with them in the middle of the night. That was still a very early stage of the software. It was really premature. Not we could run it, but we couldn't give it in the hands of an end user. So it took us another couple of years until 2011 when we officially launched the software really as on the basis of licenses and handing it over to the end customer for them to use it. It was actually a nice anecdote because the launch was done in a conference in Munich, a fiber conference in Munich. So we're based in Belgium. We went with the whole team that was working on it at that time, like 6, 7 people in 2 cars. It's about, I think, 1,000 kilometers or so. So a nice drive. But the funny thing was that we had 2 drivers, and the rest was still programming on their PC in the car to get that demo ready for the fair. And we even then needed to stop, not to fuel the car, but to fuel the laptops because the battery had drowned. So we needed to stop to recharge so they could continue working on fixing that demo for the official launch. Really a nice adventure.
Just in time.
As always.
I like it a lot.
Yeah, as always, with demos just in time. And then, of course, from there on, it went step by step. A couple of years later, in 2014, we really had an international breakthrough with real big projects like Sky in the UK, Reliance in India, Air in Ireland, Proximus, the Belgian operator. That was really where we were able to apply the software in very nice large-scale projects. And then another important milestone is 2016 when we launched our office in Toronto. So apart from Ghent office, then we had a second basis from where we could really serve the North American market in an optimal way. And so now we are growing further with about 7, 8 years over the past 4 or 5 years. So we went from 15 employees to 50 today in about 4 or 5 years. So that's been really very nice to see. And at the same time, some interesting challenges there in that growth.
You mentioned that you use the GIS data in order to do this automatic planning. Now, I would imagine that this comes with a lot of challenges in terms of data cleanliness, data accuracy, and in order to really automate this planning process. Could you explain this a little bit further?
Yes, Christian, you're absolutely right. The input quality and the necessity of good input data is really crucial in our part of the process when you try to automate this design work. So back 15 years ago when we started, this was really a problem. You really had a very big lack of good databases with this good GIS data. Over the years, of course, trend has been that there's been an enormous move towards more digitized data. Nevertheless, historical data still can be quite, the quality of it can be quite bad. But yeah, again, you do see interesting trends there, trends that help us each time to improve that input data quality. For example, one interesting project we did not so long ago with a third party was that you could use LIDAR data. So, when you see those Google Street cars, equivalent cars were driving the street, with laser measurements, they could actually bring the whole environment in 3D along with pictures on a PC. But then also with artificial intelligence, they could actually automatically recognize, for example, the footway type, which is also important because if you have a footway which is existing of like very expensive small piles, it's obviously much more costly to dig to create a trench there for deploying a fiber than it is when it's, for example, asphalt or grass even. So they could actually automatically recognize a large part of those soil types and as such could automatically feed that into our software that would consider those different inputs to automatically make the right decisions on how to deploy your fiber network in the streets. That's really very promising, and I see a lot of movements there in the market in general, which will only benefit this type of activities. Not only us, but also a lot of other things which get obviously possible through such accurate input data.
And how much would you say can you automate? So I had a recent discussion on splicing, where obviously you can't replace everything with a robot. So for those guys who are currently fiber planners, do they need to fear for their job, or is there still a need for a manually intervention or to oversee this whole project?
Yeah, that's an excellent question. In fact, I think and that's how our customers are using our software. It's not about really completely replacing the person that is responsible for making a network design by a computer. That's not also the goal or the intention. In fact, it's automation software is a support tool that will allow someone who knows how a network should look like, who knows what they want to achieve to really very efficiently create that network. And the big difference is they can spend their time at really making evaluation of options. For example, in a certain neighborhood, there may be different locations where you could put an aggregation point, like a cabinet. Mm-hmm. Now, normally when you would have a manual design process, you would have to pick a certain spot, create your network from there, and you don't have the time to really see if you would move this location to another place in the neighborhood, what it would do with your overall design, with your overall costs. And that's where the tool really can automate a scenario, but you can easily, as a user, intervene. You can impose different decisions. And that's where really the value of the experienced network planner or designer still comes in, taking control of it, bringing in maybe other aspects, but still by the click of a button and within a few minutes, getting a new design for new assumptions and being able to compare those options so that ultimately you can really make a decision based on facts and insight. And you can actually, instead of spending your time in manual drawing of lines, you could actually spend your time in evaluating big options and making the right decisions that will save a lot of costs in the rollout.
So this also means I can associate costs, so per meter below ground, and then I get a cost estimation based on my planning data?
Yes, that's also part of the input data. So on the input data side, you have on the one hand let's say the streets where you have left and right side options to dig trenches. Mm-hmm. But this could also be, for example, additional open ducts. You could load the location of those ducts where you have space available. That's geographically, but each line that you load on the input, you also indeed associate a unit cost to it. Like I was referring to before with the soil types, you can have different soil types where you would say, if I dig here, it's a different cost per meter. But equally, you can say then reusing a duct has a certain cost. Maybe putting a cable between two poles and there are certain costs involved in that. And our software is built to allow you to bring in all the options that are available in a neighborhood, associate a unit cost with it, and then it's the tool who will make the evaluation which routes based on those costs are most efficient to take. And it will list all these components in the end in a full bill of material cost overview, so that you know exactly how much this complete network, as it is designed, would cost in construction. And as I mentioned, then if you start interacting and making small changes, each time the bill of material gets updated, so you immediately see, oh, this change imposed an extra X amount of euros on my rollout cost. And that's where you really are able to make decisions based on an insight in the full cost implication of a certain decision.
Oh, that's quite interesting. In the last episode, or with episode 5 with Ryan Coles from Surf Broadband, he also mentioned that they are deploying 20-30% above ground and 70% below ground. And it's really depending on the geographics and the availability of new poles that is shifting dramatically and dynamically. So interesting to see. I did not know that you can actually feed everything into one planning software and then it updates and creates also these automatic batching and planning output.
Yes. And that's where your question on input data, for example, also comes in from the fact that if there are existing poles in a certain neighborhood, well, in order to consider them as an option, you would need to bring them in again on the input, specifying, look, here are different locations of poles where I could hang my cable between those. But then, and that's where, on the one hand, and LIDAR, for example, is also able to recognize the poles from the measurements. Great feature to make sure that you have the exact locations of existing poles to start from. But at the same time, you can then theoretically design the network. But when somebody goes out, wants to construct a network, it could well be that this pole, for example, is already fully loaded, or that it's not in a good quality state, and that you actually are not permitted to hang additional equipment on it. And that's where then the iterations start coming again, because a field check could still impose changes, things that are different in the field than from the information you have in a database. But that's where, again, with automation, you can easily select a series of poles, for example, that are in the end not reusable. And automatically the software will reroute everything to the cheapest alternative, which could be a new trench. So, okay, it will be more expensive, but at least it's the way you're going to build your network.
And this also means that if you now have done your planning, you say, okay, now let's go construction phase. So there's a feedback loop between doing the construction and then also updating the planning software, right?
Yes. And to be honest, then this is also a huge benefit for the end-to-end stream and the actual documentation of the network. That is, if you can go through this whole process from the very early, high-level design, initial footprint of how it could look like, all the way to the to-build plan, like we call it, which is a footprint of the actual network, the way you want to build it, and then ultimately between the two builds and what is really built, that's where there might still be last minute changes. Well, if you again can make those changes in the digital software version very easily, then you get a fully digitally documented copy of the as-built. And that as-built, if it's digital, you can directly link it, import it into your inventory system. And at that stage, you don't have any manual work. You actually work on a digital copy of the network, like a digital twin, and it goes all the way through your process. Each time it gets refined, updated, until it really represents the whole constructed network. At which stage it's also, and this is very important, it's exactly documented for future operations the way it has been built. And that avoids a lot of trouble afterwards of wrongly documented networks. I'm sure you've come across that as well with testing showing that things have been built differently than it should have been.
It's always a surprise for everyone.
Yeah. But reducing that surprise is a big step forward.
Absolutely. I wish everyone would do this.
Well, there's certainly a move. We have now a big project in India where they're deploying to 50 million homes. It's an enormous scale. But also there you do see they recognize the importance of the quality and the fact that through this digital framework, yeah, you can really improve the way things are being documented. So you see this adoption of the digital thing is unavoidable in the market.
Yeah, absolutely, absolutely. And is this feedback loop being done through an app? So the technician or the construction crew has an app on his phone and then updates it. How is this being fed into the system?
Yeah. You have several mobile apps nowadays. From our side, our software will calculate the network, produce the output of the design. But this data is standard GIS data. So there's a lot of GIS editing or visualization tools on tablets, on phone that can actually indeed visualize that in the field in a very easy way. And then you can redline it, for example, on the tablet, very easy because, of course, you don't want to do too many advanced data manipulations in the field, in the circumstances that you have there. But through the right level of interaction on the redlining, you can easily bring that back into the design and let the fine tuning be done. Another example there, for example, is if you design a certain network, the important locations like manholes, any structures that are built, you could actually identify them with a unique identifier and let crews in the field with very accurate GPS systems. That nowadays these accuracies go beyond imagination. But then when they really have built it and they go stand on top of it and they press the GPS button, it will automatically make a correction of you designed it here, but in fact it's built a meter to the left. Well, it will be possible to automatically update the coordinate of that structure, and everything linked to it will automatically shift along to the right location. So again, it's with one click of a GPS button that you can actually update and increase the accuracy of the documented network.
Pretty cool. I always like to geek out on these things.
Yeah, there's a lot of technology that's evolving so fast and that can help us as an industry to make our networks and our processes better.
And you mentioned at the beginning more in terms of machine learning and AI. Could you comment a little bit about this on how you use it?
Yeah, so initially, and the core of our product are the smart algorithms, the optimization algorithms that will look at for example, a whole neighborhood, a whole city, consider the design rules and the constraints of the fiber network, and will then automatically decide based on the unit cost what is a very efficient network. These algorithms, of course, are already very advanced. When I have to tell it to my mother what we are actually doing, I always tell her, look, your GPS in the car, you tell you give the address where you want to go to, and it will calculate your route. If you use maybe Waze, it may give you 3, 4 different routes and options with each time the time. Well, multiply that with 1,000 because we have 1,000 endpoints that we want to reach, not just one address, but all the addresses in a neighborhood. And that's the type of optimization that we are working on and where we develop our own algorithms to get a solution within a reasonable time for that problem. And then indeed, recent evolution of AI machine learning has been things that helped us to keep on improving those algorithms, learning from the past, learning from what works to drive the algorithms into a state where they recognize certain aspects of an area and recognize what settings behind the scene actually will deliver the best result in the end for the network.
Interesting, interesting. And what would you say is currently the biggest challenge when you design an FTTH network besides the data cleanness we mentioned earlier?
In fact, in reality, one of the challenges is that design comes as one of the first steps. When an investor wants to move into the fiber market, they'll select the area that they think is interesting, then it needs to be designed. One of the challenges is that time pressure is always on because they want to start building. I would say now even more than ever, certainly in some regions where there's like a race to be first to deploy your fiber, it means you don't want to lose time. You want to be very quick to start building your network in a certain area. And at the same time, and I sometimes compare that to, yeah, if you want to build like the biggest office tower or the biggest apartment block, if you don't take enough time to properly design it, yeah, you're gonna run into trouble when you actually build it because you wouldn't have thought of all the different aspects and options. Yeah, under that time pressure, still to be able to ensure a very high quality design. That is really always in projects a challenge, and where in fact, I always tell my customers, look, it's the worst idea ever if you want to try and really save time in design and money in the design phase, because you're going to pay back tenfold in the construction phase and you're going to lose time in construction. But of course, sometimes, yeah, they do want to just be out there in a certain region the quickest possible. So we have to cope with it somehow.
A lot of post work done, and as you said, we see it currently in some regions in Europe where it's trying to build a quality network at pace and seeing where I can maybe cut corners a little bit so it doesn't hurt my network for the next 10, 20 years too much.
Exactly.
But I still have a lot of I told you so moments. But you wanted to actually cut this corner, so here we go.
Indeed, indeed. Sounds familiar.
So now that you already mentioned LIDAR and machine learning, where do we go from here? So what is the future of ComSoft?
As a company, our ambition is really to bring this automated design to the biggest possible scale. In fact, last year we had an interesting internal brainstorm about what the company's mission would be, what our so-called BHAG, a big, hairy, audacious goal would be, and one of the options we still kind of need to finalize it, but one of the options that was most appealing was to say, look, we would aim to get 1 billion people worldwide actually having a network connection designed automatically with our software by preference by 2030. We are currently around 200 million already, so a number we are quite proud of. But nevertheless, that's still a long way to go. But that's of course where our ambitions go to. And as a company, that there's two things how we want to achieve that. One is, yeah, of course, keep on improving the fiber part so that we can support more different projects with different challenges. So that's a continuous improvement process. But also we believe and we are working in an innovation track that this technology, this concept of automating the outside plant and the infrastructure could also be applied to other utilities, especially in the energy market. There's also a lot starting to happen. Actually, also a lot about communication. So our first introduction into the utility market was through smart grids and the need of communication in those grids. And that has led to exploring how we could also automate the design of energy networks, district heating, future power grids that would be able to cope with the growing need for electrification and energy in a climate neutral way. So that is for us as a company also an ambition to expand into new verticals. Although, yeah, like I mentioned, I started 22 years ago at ComSoft around fiber. So I'm also pretty sure I'm never going to give up on that. That's my passion.
Cool. You mentioned you did a case study on the LiDAR and getting a more accurate data and a white paper. So is it available for everyone to read, or is it more on a private matter, or can we link it in the show notes?
There is certainly material available. There's probably some recording of a demo video and some webinar material. So yes, we can certainly also share something to be linked in the notes.
Cool. Because I know my audience is also quite geeky and they would be interested in learning more about this as well. So I'll definitely put something in the show notes. Besides that, Raf, where can people learn more about you and ComSoft?
Well, you find, of course, everything on our website, comsoft.com, where there's also a lot of white papers and client testimonials. But I would say also personally, I'm very heavily involved in Fiber to the Home Council in Europe. This has been something I've been doing also for almost 10 years now, being involved in trade fairs, but also in activities around DNO committee, cost models for Europe. And recent, a whole study we did together with a lot of other members of the council on convergence with 5G and how the whole 5G is actually an opportunity for the fiber construction. Yeah, we contribute a lot. And actually, since last year, I've also been elected for the board of the council, which has been an honor for me as well to help there. So I think there is also a lot of valuable content around the whole fiber thing. We are, for example, working now on an update of the Fiber to the Home Handbook, which is a reference book with a lot of information in general on fiber in all its aspects. Design is one part of it, but also all the other aspects are touched upon. So there will be an update of that, which is really highly recommended for somebody entering the market. It's like an encyclopedia of everything around the fiber networks. And of course, there's then also for example, the yearly conference, which is a great opportunity to meet with all the industry in Europe, which now will be, unfortunately, one more time virtual, and hoping next year we could actually meet in person again, which we are longing for a long time now.
Absolutely. I always enjoy now currently when I do my customer visits to actually get out again and see new people.
Yes. It feels like ages ago, but we'll need to get used to it actually again. Meeting people coming close to each other, it's like, ooh, this is dangerous.
Right. Perfect. So thank you so much for joining.
Yeah, my pleasure. Thanks, and I'm looking forward to see more of these episodes. So really interesting stuff.
I appreciate it. I'm seeing myself quite fortunate interviewing such an amazing guest like Raf Meersman and getting his insight into his mind of fiber planning, and that actually the importance of auto design also in relationship to quality versus efficiency gains was a quite interesting insight from his perspective. Clearly what Raf and his team is doing is working. And he mentioned the Reliance project in India with 50 million homes connected. And just imagine the planning you can do and the automation you could do with auto rerouting and changing the bill of material for 50 million homes passed project is just mind-boggling big. And personally, I agree with him. Choosing to save time and money in design is one of the worst things you can do as an investor and as an operator, because this is definitely going to bite you back tenfold in the end. So making sure you have a good starting basis is key for a successful network deployment. And you might have noticed I also like to geek out a little bit on these things like machine learning, LIDAR, and AI. And seeing this being also applicable for fiber planning is certainly interesting. So with that, thanks for listening to this episode of Become Fiberminded. If you enjoyed this episode, I would appreciate it if you could do me a quick favor and rate and review the podcast. This shows the platforms that I'm doing something right and that people like the content. And if you learned something new, tell a friend or a colleague about the podcast so I can help more people. Be sure to go to fiberminded.com/episode 6. Once again, fiberminded.com/episode 6 to see the show notes with the links mentioned in this episode. Until next time, keep connecting the world with fiber.